The next talk will actually discuss this, how you can actually have secure running services on Docker containers. The title is AppSec in the Time of Docker Containers, and will be presented by Mr. Akash Mahajan. Uh, the speaker want to introduce himself, and I think he might know himself better. So, yeah.
Hi, good afternoon. Hi, good afternoon. I always do that after, if the talk is after lunch. I think the previous speaker did a fabulous job. I loved your presentation. I learned a lot about instances and pricing today. So hopefully I can, do justice to and make sure you don't sleep today. Cool. So I'm actually not going to talk about what Abhishek said. Uh, sorry about that, but I will talk about application security. And I will try to take you through a journey on how I have discovered what's really happening when there's an information overload on DevOps to start with, and all these orchestration and provisioning and deployment and automation and all of that. Okay. So wanted to introduce myself. My name is Akash Mahajan. I'm a director at a company called AppSec, which is why there's a director's chair there. I wrote a book on a tool which is used for application security called Burp Suite Essentials, which is why there's a book there. I'm an active member of communities in OWASP and NULL. NULL is India's largest security community, open security community. You're welcome to join us. I am the chapter leader for the Bangalore thing at OWASP. We do monthly meets, and I'm also a trainer. In case you're wondering why there are shoes on the. Nope, not funny. Okay, cool. Thank you. I've actually planted around 5 people to laugh so that the others can join in. I don't think they're doing their job well. Or maybe they're in a cluster right there on one side. So, uh, nobody ever said, right, that there are only 5 types of security approaches. Nobody, okay? It's not a quote. But it's good to start with a quote. So, when I started taking Docker seriously, okay, and I apologize if you prefer, is it RKT, Racket, Run C? I don't know, there are a bunch of them. Okay, when I started thinking about all this, I just read about Docker, so which is why this is how I felt. An outsider looking in, and if you notice, the person's outside. If they're watching a TV screen, obviously this short person can't see what's really happening on the screen. And I felt that there is this whole thing where people are talking about application environment isolation, and I'm supposed to know application security. So I felt really weird. You've heard of the imposter syndrome? Okay, I can't understand nods. So yes, no, cool. Someone just jiggled. Cool. So what did I do to deal with it? Okay, the syndrome is that you think that you know some part, the blue circle on the left, and everyone around you knows so much more, which is maybe true, but to deal with it, what you think about is, I know some things, and that overlaps with what others know, right? That's what I'm trying to do here. So, as the previous speaker said, please be gentle. So the question is, how do we do application security? The images all have like deeper meanings, so you have to pay attention. So this one is, if you notice, there's like a metal fence kind of a thing in front of a building which kind of looks like it's old. Yes? That's typically how application security happens. There's a lot of legacy stuff, and you have to bolt on security. And you hope that whosoever wants to get past is not tall enough or does not come with a crane. Do you see the crane outside moving the huts? Right? So, yeah. And I can't see my note share, so yes, legacy buildings, modern fences, gates, back doors, rusted locks, and sometimes keys get shared. I'm pretty sure in your automation, you've always had to wonder, where do I keep my secrets? Right? Bunch of you have plonked down the $5,000 per month AWS service, KMS, but maybe you're not, or you're using the HashiCorp thing. This is one of the approaches. This is what automated scanners do. Automated web application scanners, the hammer nail thing, right? To a hammer, everything looks like a nail, right? And when your people or your management or bosses or teammates are like, oh, we need to implement security. What is our security strategy? Typically, we are like, let's buy this tool. Anyone gone through that? Nobody? Yeah, a bunch of you. Cool. So it seems like, some of you are doing this. I usually get a lot more responses in some other conferences. People use automated tools. This is what bug bounty enables you to do. Are you familiar with bug bounty? With bug bounty, you win some, you lose some. Has anyone had to deal with a bug bounty hunter as part of at least one person? Thank you so much. So you will always laugh at this, okay? This never gets old. Full marks for trying, right? But the kick, oops. Cool. And sometimes this is the experience you have when there is a smart hacker or a pen tester. They just slice through your infrastructure. Yes? Well, this one's supposed to evoke, awe and wonder, not like laughter, but whatever works. So sometimes you have that experience where you're like, this seems like an intrusion, this seems like an incident, but we're not really sure what happened. Anyone? Okay, cool. Thank you so much for sharing this one, because most people are embarrassed about it. This is what really happens when you do application security. Right? There are a bunch of checklists, Excel sheets, and there are these things about secure development practices, secure deployment practices. All of that has to happen, and it's really boring work. And a lot of people think that hacking or doing security is glamorous, but most of the time it's these boring parts. And if you think this slide is doing too much, there's like too much stuff on this slide, it's by design. Because most of our day job is like that. There are a bunch of things to take care of. And when I take you through the journey, I'm going to try and simplify this for you. Okay? So that you can answer the question, what do I do next? Maybe on Monday, maybe once you're done with the conference hangover. But for my benefit, and if there is anyone else in the audience like me, we will start with what is a Docker container. Is that okay? Thank you so much. It's a container, and that's how I understood it to be at the beginning. It allows a developer to package applications and all the dependencies. Because nobody likes to deal with dependencies and circular dependencies, or when you install a Node app, you just do like a npm install something, and then you realize that, oh wow, it's like downloading some 100 of them. Did you guys read that one where someone wanted to know why a particular install downloaded some 27 MB of data? Right? And then they figured out most of it is because of the picture of the creator of one of the modules, which gets downloaded. So Docker allows you to kind of bypass that, right? This box is basically an isolated environment. We will put this to test. Is it really isolated or not? But it's not saying it's secure, but there's an isolated environment, and the application has everything it needs to run. That's what we understand about Docker. Cool. And this is a chart that I saw on Google Trends where 100, I don't think the pointer is working, but towards the end, it's at 100, which is like the peak popularity for a particular term. So Google Trend is saying there are more people searching for Docker, which means that definitely there is some popularity to be had. Is it developers searching? We don't know. Or it could be clueless people like me, but all the same. Okay, and if charts are not really your thing, you can have a nice graphic. Okay, containers everywhere. Because at one point, how many of you follow Hacker News? Well, at one point it seemed like there was nothing else in this world. And like, what happened to all the other stuff? Right? And obviously, I guess it became really more prominent after .cloud became Docker, the whole rebranding thing, where they got a ton of money. So why is this change to Docker become imminent? That was my question. Right? Imminent means it's going to happen now, not sometime in the future. Right? So that was my question, like, why is the world moving to Docker so quickly? Right? And this was like, if we had, OWASP has this document called Application Security Risks Top 10, okay, Top 10 Security Risks. And usually they have a cycle of around 2.5, 3 years. So the last one came out in 2013, we're expecting one in 2017, okay? So more than 2.5 years. There is no way whatever they're going to come up in 2017 will talk about this. Because the document is based on data collected over a period of time about applications which have been deployed, the attacks that they have seen, and then it's like a weighted list. They have figured out these attacks are more likely to happen and cause more damage. Right? So Docker is going to be there. That's what it looks like. We don't really know, but it looks like. So this is what I believe the reason to be. I am not going to jump on the stage right now. Old people in the room who know the reference? At least one person, two people? Okay, thank you so much. So I'm glad a few people get my references. It's developer productivity and now it's operational productivity, right? That's the whole game. That if the environment remains the same, we are not going to be troubleshooting some random Node or C library or PHP library which got missing in the production, right? And the entire app is not working because of that. Okay? So this is what I feel should happen. And if developers are going to be using Docker, we have to think about how are you going to think about application security for them, right? Because if that is what it is going to take, then we have to figure out what happens next. And regardless of how much security folks, I'm a security person, we think that our opinion matters, nobody gives a fish. My mom's in the room, so, no bad words. And I learned it the hard way. This lesson I have learned many times. I stole this from a really nice article on the Docker technology preview, where basically the container can run in the laptop, run on a server, run in the cloud, and someone who definitely pushes it to the hub can just consume it. Makes it really, really simple, right? This is well thought of. And if it's simple enough for people, it's really, really useful for them. Some people had this question, and I was like, but this is like, we have had jails and ch root and stuff for forever. I try to avoid using it when I can. And I tend to think I'm good on Linux, compared to Windows. But this is what, Docker allows me to do. So this is, Mutal is like a vulnerable application. It's a deliberately vulnerable application if you ever want to practice doing web attacks in your safety of your own laptop, which requires PHP, Apache, MySQL, and a bunch of things to work together. And this PHP part also has like some dependencies and whatever. In the Docker world, it's like just figuring out which package or which project it is, image it is, and then just do the port forward part and or specify the environment variable. It doesn't matter because MySQL is running on localhost. It's not being exposed anyways, and I'm not doing anything with the DB. So this is simple, and if you have something like Kitematic, it's simpler. Right? Maybe you've tried this tool. It makes it even simpler to figure out the port stuff, right? So if a developer has to choose between being productive or being secure, more or less he or she is going to choose productive. Do you all agree? Great, because this is what happens then. So security folks are like, why would you do that? Why would you take a random bash script online, and just download it with curl and pipe it to bash? Yeah, sudo bash, right? Oh, I forgot. I think it was not fitting in the, because I really wanted the GIF in. So, but it doesn't matter. Because I went and started looking for examples of this, and there's really nice Tumblr for sudo bash. I don't know if you've seen that. And someone talked about Dice here today, or OpenShift, right? A bunch of these platforms, the way you get started with them is by using this command. There may be a paragraph about this may not be the ideal way or secure way, but nobody really cares, right? And someone has done a POC that they can figure out if the server can figure out if the client is using curl or wget to pull some kind of a file. And if that's happening, they can send something else. And in this case, if you notice, the path is over HTTP. So it's open to MITM, man in the middle, right? Someone sitting in the middle can change the script that you get. There is no way of checking integrity, but it doesn't matter. So we have to live with this reality. So when we talk about containers, where does the AppSec and the OWASP part fit in? These are the relevant risks. So what I've done is, rather than look at the 10 risks, because OWASP top 10 is a horrible list. It may be data driven, but it's a mix of stuff that can harm your server and stuff that can harm your user. If it is going to harm your user, that execution is happening in someone's laptop or desktop, right? Your server is not impacted. But if you're deploying containers, we are worried about the server. So these are the 4, well, are they 4 or 5? 5, okay. 5 things that we should look at. And to simplify, rather than being technical about it, I'm just going to use normal English. Injection is stuff that's going to harm your computer, your server. Broken authentication is an insecure direct object references is stuff that lets attacker attack parts of your application. They are able to access parts of your application and then harm your server. Okay. Misconfiguration, I think the easiest one to understand is stuff that makes infra supporting the app insecure. And when you use components with known vulnerabilities, that stuff will enable something else to cause the problem. Third-party stuff. Okay? Don't worry, I'll explain a little more and be a little more technical if required. You can also include A6, which is sensitive data exposure. And there are like 60% of the OWASP top 10 is relevant to you guys, if you plan to use Docker for production stuff. Injection is, I saw a really nice presentation yesterday, and I was like, rather than trying to explain it the way I usually explain it, I should show nice boxes. So attacker is attacking your application, it is immaterial if it's running in the container or not. What they can gain is data. If there is a vulnerability of SQL injection, where the user controlled parameter is going to, without validation, it's being sent to the SQL interpreter, right? If user can control it, they can control the delimiter as well, right? SQL has a delimiter like single quote, double quote. If I'm able to send that, then whatever data I'm sending can become a command, right? Standard SQL stuff, it's been there since 1999, right? Because of that, because of XML entity injection, there are other things possible, like gaining access to files, credentials. There's a really nice talk, I'll put in the references, about stealing secrets from cloud for fun and profit. It's about AWS meta instance data that's available if you do autoscale, right? And that's really possible if you are able to make requests to something else while you are on, the request, originates from the server itself, right? It's called server-side request forgery, and there are a bunch of interesting things you can do with that. You can also gain shells. Now, the cool thing with the container is that if I gain a shell and I want to list out the users of that, and I may not know it's a container. I could be in a reverse proxy, and then I don't really know if it's a container or not. The list of users I'll get is from the image, the standard image that you pulled from Docker Hub, or maybe you have a private registry. Because typically attackers want SSH access, so once they have usernames, they will start their brute force, scripts to try and figure out the passwords. Okay, so A1 injection is the one that you have to worry about, and A1 injection is the part that most automated scanners really struggle to find. Neither can they, ensure coverage, nor can they ensure, that there are no false negatives. You understand? A false negative is when they believe there is no error, but there is. The vulnerability exists. Okay, and command injection can cause all of these. If there is a command injection somehow, it'll cause all of this. To explain broken authentication, I have taken the help of a celebrity. Do you know who this is? Yes. So Paris Hilton, this is a really well-known case in how there are various parts of authentication that can be broken, and this particular case was about a backdoor in terms of forgot password feature, right? So she had a phone called Sidekick. It's some kind of phone that you get in the US from T-Mobile, and the good feature of that phone was there was automated backup of contacts and SMSs to the server, so that if you ever lose your phone, it's very easy to get it back. The problem was it had a forgot password feature on the website, which was asking the secret question without authenticating if this is the right person asking the secret question. Okay, so the secret question was, oh, I don't think it's visible. The secret question Paris Hilton had said was, what is the name of my pet? Because she's a celebrity, there's a Wikipedia page for her, and the name was Tinkerbell. Sadly, this doggy died now. It was a 14-year-old Chihuahua, which itself is a miracle. But that was not a joke. Strange audience. Fine. It's okay, I'll take it. So there are many places authentication can be broken, right? If you look at the OWASP guidance for this, they will list out around 6 or 7 different places. But the point is that if it is broken, it doesn't matter if it is bare metal, virtual machine, virtual environment, right? And if this allows elevated access, in this case, the attacker basically got the phone numbers of other celebrities, and they're able to sell that kind of information to tabloids, and they get money out of it, right? There is some resource or something available which will someone is willing to pay for, which is what is attractive to the attackers. Insecure direct object Abhishek in the room? I was told I have 1 hour, but it's showing 11 minutes left. Okay, cool, thank you. Insecure direct object reference. If you really want to understand this, start reading it from the reverse. It's a reference, it's an object reference, which is done insecurely. Okay, an object reference the object can be a URI, it could be a path, it could be a special ID, it could be some sensitive information. The example I have for you is this. Does anyone remember this case with this guy called Weave, who managed to get into, they claim that he got into an AT&T server and stole the contact details of 144,000 Americans. The case got massive coverage because one of the Americans was the president of the US, Barack Obama, right? His iPad also was, that information was also leaked. The case was finally dropped because all he had done was this. He figured out that AT&T had a web page, an endpoint, where you could get more information about the iPad that you have bought from them, and you had to provide the device ID. These are just random numbers, this is not the actual device ID, right? And he also figured out that he could get, if you change the device ID, he would get the information of someone else. So it's a direct object reference, but it's insecure. Because ideally, what is this? This is a bypass of authentication and authorization, right? Not only this information should not be public, it should be protected. Because if I have a tablet, my data should not be visible to someone else. And another really big case is where Citibank lost some 300,000. They were fined $300,000 because they managed to goof it up, and by just changing the account number, you could see the details of someone else. Okay? And sometimes developers tend to hide this by doing base64 encoding, right? But encoding does not require a key, which means if you understand what algorithm was used to encode, you can decode, right? So what he did, Weave, basically he's supposed to be a big troll on the internet. If you're Googling for him, please enable your NSFW filters. I'm not responsible. But he figured out that he could script this. Because what are you doing in the end? You're generating a bunch of URLs where the ID is sequential, right? And this is something that we find a lot of times, and it's not going to change just because there is an isolated environment. Can you tell me what's wrong with this image? Security misconfiguration? Say that again, please. Yes, the actual processor and everything is on the tablet part. Seems familiar? Where the hardening or the security was applied to a particular layer, but that was not really effective. No? Okay. The big money is in the part which is not locked, right? It's like a retail store somewhere, and someone posted it on Twitter recently. So I was like, security misconfiguration is a big one, right? Because in terms of application, an application sits on top of an entire stack. The problem could be at the physical layer. If someone just walks off with your server, there is no security. It could be at the network layer, right? If your the IP is spoofed, or the LAN itself has a problem, a bunch of security assumptions that go for a toss. At the layer of DNS, if the DNS is hijacked, I don't know what happened. If the DNS is hijacked, you are relying on DNS to give you the A record for a host or a domain, and you don't really know if it's the actual one. It can be at the layer of transport, where remember Heartbleed? Did anyone have to patch your ELBs and wait for like 2 days because AWS did not tell you, right? They got a lot of grief for that. And it can be at the application layer, it could be at the web server, it could be in the reverse proxy, it could be in the language itself, it could be the framework being used for it, could be Spring, Rails, whatever, right? Django, Flask, PHP has had a bunch of them. So this is a big one. But rather than trying to go in depth there, let's look at what are the main steps if we are talking about application security in the time of Docker containers. When someone has to test stuff, right? If you have like a security process, there is stuff that has to be tested, application has to be tested, right? You have to set it up so that you call it testing, some people test on staging, some people test on production, whatever you call it, right? There is this whole thing of testing applications. There is this other thing about secure development, right? Secure development? Heard of it somewhere? Urban legend? Okay. Maybe your devs have. Maybe only the ops are here. So That was a joke, but well, you can do pre-configured Docker files. You can do a bunch of things. They have content trust and all. And then there is secure operations. Maybe that's the one that you really identify with. Running Docker in secured, isolated instances, right? So these are the three things. If you have not really thought about security, and in the end, if you are running containers, what is the point of running the container? You're serving some applications, right? Yes? I mean, it's cool and all that, but in the end, the application does get served, right? There is a customer who doesn't care about if it's a container or a VM. So these are the three things that you'll have to do. And how do you test against stuff? You basically have your browser, maybe you use an interception proxy, because that's what I like to use. The ones in the middle are the interception proxy, and maybe those are your servers, right? Using an interception proxy, you're able to see each and every request that goes to the server from the app, loaded in your browser, and all the responses come back to you. And because the interception proxy is, kind of like a history for you, you're able to go back and see, oh, these parameters were sent, this was the response. What happens if I change this parameter here, right? What happens if even though I'm using a Mozilla or a Firefox, or a Chrome or a Firefox, I pretend to be an iPhone. Okay, Facebook had this really cool bug where for their mobile login, their mobile browser login, the m.facebook.com, they would suggest rather than using the full password, you set up a 5-digit unique number, right? And they would just check. That was only possible if the user agent was a mobile. But if you have an interception proxy, it doesn't take a lot to just change your whatever browser, desktop browser you have to act like a mobile. Now you can do that with DevTools. Whenever you do your mobile first responsive testing, right? Some of you might do that. So this is what's going to happen with this. Docker containers will make it really easy, right? Because app is Dockerized. Additionally, your security tool can be Dockerized. That's useful, right? Because what you have then is maybe you're the expert in your organization, but you have 10 other people who also need to do the same thing you're doing. But you don't want to waste time configuring their interception proxy exactly the way you use it, right? And especially Zap, I don't know if you're familiar with it, is a fabulous tool. It's extensible, it's open source, and it has things like where you can create the specific set of checks, security checks you want to do for your application. Okay? And right now I just can't remember what it is called, but with that you have a customized scanner for that application. And just Dockerize it. So what do you get? You have like 10 different ways of doing your Zap, right? So that's useful. So in testing, this is where Docker can be useful, and that's what my discovery was. This is where I can use Docker. And for all testing, I consider an app equal to an API. An HTTP REST-based API is no different from an app. It's all the same kind of testing. You may do a little more authentication, authorization testing, when APIs are concerned, but it's all the same thing for us. The secure development thing is being secure by default. Why is this important? How many of you have heard of the Mirai botnet? How many of you were impacted when DIN went down? Dynamic DNS? Nobody? Well, some of you, right? So that particular botnet was responsible. The sad state is that there are a list of around 36 or 40 username password combinations which are used. Is there a bigger number or lesser number? Okay, 68, sorry. But basically there are a bunch of devices online which are connected to the IPv4 internet right now, where admin credentials were one of those 68 things, right? So someone was able to create a botnet and attack something else. When you do secure by default, that's the exact opposite of that. You want to make sure by default you're able to be in a place where there is security in place. Security requires some kind of measurement, verification, validation, and it is able to give you assurance. So if you are working with a registry, maybe it's the Docker Hub, if you notice the green squiggly thing is a signed image, right? This is the default you get if you're using Docker Hub as a, when you're doing Docker pull and all that. What you want to change it to is content trust enabled. It's an environment variable, right? So if you enable this and if you use something called Docker Notary, which is basically to enable trust so that you don't have to rely on the public Docker Hub and the signed packages there, you can have your own publishers and do this, right? But if you haven't looked at, this is something you should definitely look at now. Before you have, ton of containers in production and you're not really sure, are they all using the Alpine base image, or I'm paying more to AWS for disk storage as well, right? Something like that. For secure operations, for the servers or the places where your environment is going to run, you basically have to do all of this. Anyone from Red Hat in the audience? So if you have any SecComp questions, SE Linux questions, ask them. Only they understand how it really works. Okay, most of us have learned that, oh, SE Linux disabled, and yeah, we're good to go. How many have you done that? I've done that. There you go. So, no, that's why I want to talk to you, right? Go to the expert. So if you want to do secure operations, based on what Docker is suggesting right now, you have to figure out kernel namespaces, control groups, capabilities, syscall filtering, mandatory access control, which is the SE Linux and the AppArmor part, right? So far, what I've been talking about is like easy stuff. Security has to be easy. This does not look easy. Anyone in this room who thinks this is easy? Let's just get that person to continue the presentation. But so what's our hack? What are we going to do to figure this out? If you are responsible for containers, as part of your production, I really recommend that you read this white paper by NCC Group. It's called Understanding and Hardening Linux Containers. They talk about the CoreOS Racket, Docker, and LXC, the canonical thing. And for a company, NCC Group is a massive security company. What they have managed is it's basically a book. It's around 85, 90 pages of pure gold information. You just have to start there. If you are like, I don't even know what these terms mean, that's the thing you have to read now. Okay? It's part of the deck. I'll just upload it on speaker deck, so you'll have the link. But that's what you have to start with. Okay? But again, we don't have to manually do this. What we should do is follow the CIS checklist. CIS is like Center for Internet Security. They do a bunch of things, and they have really good checklists for RHEL and all. I'm guessing there is this because RHEL certain versions are the only things that can run with US Department of Defense or something. So there may be some connection there. But the checklist for Docker is really useful. You get list items for host configuration, daemon configuration, files, permissions, and configuration files, container images, runtime, Docker security operations best practices. Again, if this seems like too much work, you have to start with the Docker bench security script. If you're not familiar with this, it's on GitHub. Just run it against your container. You can actually run it against a standard Linux machine. It will still give you some good information. Whatever is in the CIS checklist is covered in that script, right? And again, I'm not saying that don't deep dive and figure out what's relevant for you. But this is like a good starting point. You already have the reading material. You have a tool that's going to find out stuff for you and give you some warnings, errors, or things to watch out for. That's what you should start with. If you want to, and if you're inclined, and if you like to try breaking out of things, play this browser-based game called Contain.af. It's written by this lady called Jessie Frazel. if you are in, if you're familiar with Go and Dockers and containers, you may be following around GitHub and all. Anyways, so there is a benchmark report for that particular, checklist that we saw. If you're into reading boring, dreary reports, that's your thing. And I don't think we need to really answer this question, is Docker safe for production? Because 6 months ago, I think it was a valid question for a lot of us. But now, a bunch of companies run large container clusters anyways. But that's how you can get started. To do the AppSec part, you should test the application as you normally would. You find security issues, you report them or do something with them. You do the white box assessment. This can't be done, a black box. Someone needs to have access to that, the container for doing this with the checklists. This is really important. You have to keep track of any privilege escalation bugs that may crop up. It could be in the hypervisor, the underlying VM. It could be anywhere, right? And understand the software supply chain. Pick secure alternatives. If you have containers where there is like a node package sprawl and you have no idea what kind of packages are running, you should definitely evaluate running a private repository or maybe even Docker private registry. But before we go to that, let's cover some fails. I really like this one. Just for your benefit, it'll repeat. It's funnier the second time. See what a one well-placed hit can do? It's like you can't stop watching it. There it goes. It's app for containers, right? So some dev oops movements. There's another really nice Tumblr for this. You should have a look at that. We have a really talented guy, Avi Coder. He's part of the Null Bangalore, community. And what he found was that he told us about this in June 2016. He found a subdomain for Wine. Wine, the Twitter app, which I think now is shut down or is going to get shut down or something. He basically figured out they were using a private Docker registry. They were using the version as 1.0, which had no authentication. Which basically meant once he had the endpoint for the private Docker registry, he was able to pull all the Dockers, including the source code of the Wine app. And obviously, they paid him like a ton of money for that. And Twitter has this weird thing, they don't pay in whole numbers, right? They pay some random amount. And he blogged about it, so maybe you want to have a look at that. It was something that was avoidable, but just be aware, if it's on the internet, right? And if the endpoint has words that can be found in a dictionary, not like your, the old that Oxford dictionary and all, but like regular English words, then someone is right now scanning for it. Okay? People who do ops and actually look at logs might be aware of that. This was the image insecurity issue. This is fixed now. That's another recommendation if you can. 1.10 is when they really became serious about security. The issue was the way the image was compressed. It was an XZ format. And in C, it was not safe for memory. And if you would exec it as a root user, if the compression format had a vulnerability, right? Just because you were executing as root, you could, it could result in a complete compromise. And it had some airplay when it happened, but it's no longer a vulnerability. But you need to understand that what you are using is built on a bunch of things, right? And this is not exactly a Docker issue, but this should kind of, something that you should always be aware of. That credentials, secrets, which are left lying somewhere can be problematic, right? The code space thing is like really, really tragic, where a lot of customers lost all their source code because while CodeSpace was a third-party code hosting company, they allowed, they basically were using the AWS root user for all their operations, right? So if you have ever been there, you know how damaging it can be. And as I said, you have to keep track of privilege escalation issues. So if you have not heard of Dirty Cow, this is a recent local privilege escalation bug that was for Linux kernels. But because you're basically running on top of that, there is a POC to escape a Docker container. So while in the container, you may not have secrets. But outside the container, that particular user may have the privilege to see the environment variables, right? Or your .netrc file, or your tilde/.aws file, aws/config file, right? That's how you do your AWS SDK. So you have to be aware of these. Cool, I'm done. Questions? There's a question here.
Hi.
Hi.
Yeah, not so much a question, just an addition to what you already said.
Sure.
Because yeah, many people realize Docker now has a feature that allows you to do image signing, but pretty much nobody is using it, even though, as you said, the hub provides this automatically.
Yes.
But the bigger issue behind this is that many people still rely on the basic tag to identify a Docker image.
Okay.
So even if you have the image signed, as long as you have an automated procedure that basically generates this image, there's always the possibility that somebody else will replace your already deployed image with the same tag, and you are not even wiser. So you always have to keep track of the hash that is actually identified, that actually identifies the image itself. If you don't do that, you will fail, and you do everything else, you will still fail in security, especially with Docker.
Cool, that's really good to know.
Hi, so I work for ThoughtWorks, and we have really interesting clients. So one of these places, we need to deploy some stuff at really remote places, like in a really corner of Ethiopia and stuff like this. So the first thing is there is no internet, and the second thing is so the transport, it's physical transport. So whenever we are supplying updates, it's basically Docker layers that goes into the update. So to simplify this process and minimize the amount of data transfer, we went with Docker layers. But then the problem arose, we have 3 containers, like one is app server, the other one is a Postgres server. So, and we really don't trust the guys there.
Okay.
The people who are running this. So they have been hired on spot, and then we don't really know how that thing works there. But then, so where do we store the Postgres credentials?
I do not know the answer. But they have access to the container, right?
Not the container. All they can do is SSH into it, but then once in a while, a really cool tech guy comes.
They have Dirty Cow to become root.
Yeah, we fixed that patch. That's not there. But then somewhere in the, so the other part is when we supply updates, it's via an encrypted zip file.
Okay.
And we don't want a human decrypting it there, but it's still a symmetric key, right?
Yeah.
So somewhere we need to put the password, right?
Yes.
So where is this place? Like,
there is no solution for this.
okay. So right now,
If you cannot guarantee, right, there are 4 guarantees that you need to have. You can't guarantee physical security, right? Your network security, your memory and CPU, right? If these are not in your control, then you can't do that. Like this is the same problem with the mobile device.
Okay.
You do not store your AWS credentials as part of your mobile app. Maybe if your your backend is in AWS or something. Why? Because you don't control the CPU and the memory. There is no way for you to figure out how that key will be read securely.
Right.
You don't have any protected memory or any kind of storage.
Right now, the thing
But
that
what will happen? Like the question can be answered in this way: like what will happen if they have the credentials to the Postgres DB?
Like I said, we don't trust the people there.
No, I understand. But you may want to like a threat model, like what can they do with that access? And is there any other kind of fraud check or something that you can add?
Right. So for now, we went with a really obscure place to store the key, but then even the app needs to decrypt it in order to read the Postgres data.
Obviously.
But then that's the best thing we could come up with right now. Like, if you have any better ideas around.
Maybe if I think of something, I'll let you know, but I don't think so, but yeah.
Okay, thank you.
Ask simple questions, please. He said, be gentle. I'm kidding. It was such a fabulous talk. You have no questions. I'm so grateful. I think they're all waiting for the tea break. Thank you so much.